Right, section 1.5 is, today we're going to be mostly doing an intro to system of equations. It's mostly going to be a review of this equation right here. And how to graph. Okay, so what are some things that you guys talked about? What do you know about this equation? What do you remember? Anything. What do you remember about this equation here? And you spent a whole year on it in Algebra 1, so you should know some things. First of all, does this look familiar?
Yeah.
Okay, why does it look familiar?
I forgot like everything about it.
This is slope-intercept form. Everything I write down, you write down. Slope-intercept form. Okay. These, what we're used to the last couple weeks here, what does this graph turn into? What does that parent function look like up at the top? What does the y equals x graph look like? Remember, we had that one, we had y equals x squared, and we had y equals the absolute value of x. What does this graph look like?
That's,
Isn't that a slant?
Yeah, it looks like a line, right? This graph gives us a line. Okay, and this equation helps us graph the line. Okay? In this equation, our slope-intercept form, it gives us two important pieces to graphing. Okay? And that has to do with the B, and that has to do with the M. Okay? Does anyone remember what the B stands for? No. As a part of the graph, it stands for our y-intercept. The B is our y-intercept. Okay, and the M, that stands for our slope. Okay, we know slope as rise over run. Okay, and I want you to think of the y-intercept as our starting point. Okay, so as a little example here, you do not have to write this down on your graph. Okay, but if I had an equation, y equals 1/2 x plus 2. Okay, what is our b value in this? 2. Okay, so that's where I plot my y-intercept on my graph over here. I'm going to plot it at 2. That's my starting point. Okay, the slope helps me get every other point. Okay, so our slope is 1/2, so that's rise over run, so I'm going to go up 1 over 2. Up 1 over 2. And then you keep going until you can't go anymore. Does the line only go this direction? No. Do you agree it also goes this way?
yeah.
Okay, so we have to get all the points that are possible on this graph. Okay, now we have our line created. Okay, we're going to be reviewing how to graph these lines today. Okay, so to start us off, I want you to write these two equations down, and on your graph paper, go ahead and draw an x and y axis because we're going to be graphing. Okay, you do want to make them fairly large, so maybe take up like a quarter of your paper. Okay, so here, talking about systems of equations, which this section is all about. Okay, what that means is we're, instead of just graphing one line on a coordinate plane, we're going to be graphing two. Okay, but they are graphed the same exact way. So let's start off with this first one here. I'm just going to call this equation 1. If you have like different colors and you want to graph your lines in different colors, you can. You don't have to. Okay, but we remember we have our starting point B. In my equation 1, what's my starting point? 2. Okay, so I'm going to go plot 2 as our y-intercept. So I'm going to go up 2. There's my starting point. Okay, to get the rest of the points, we need our slope. What's our slope? 2/3. Okay, now, I got a little ahead of myself, but if you remember, we either have a positive slope that goes up, or we have a negative slope that goes down. Okay, right now, do you agree this is positive? Okay, so our line should look like this, because we have a positive n value. Okay, if we have a negative n value, then our line is going to go in a downward slope. Okay, but right now we have a positive slope at 2/3, so I'm going to go from my point, I'm going to go up 2 over 3. How far do we need to go? How many points do I have to do? Like, can I just stop there?
No, because you know
Yep, you want to do the whole graph, and I'll explain why here in a second. You want to do the whole graph in all directions. Okay, so go ahead and plot that. Once you have your points, you can go ahead and connect your line, or connect the dots. Okay, so right there is my first equation, or my first graph. Okay. Now we do the same thing with graph number 2. Okay, so again, what's my starting point or my y-intercept for graph number 2? 3. So I'm going to have my starting point at 3. What is my slope? 1/2. So we know it's positive, so we know it's going to go in an upwards direction. So from my starting point 3, I'm going to go up 1 over 2. Up 1 over 2. Up 1 over 2. And you want to go as far as you can until you can't go any farther. And then once you have all of your dots, go ahead and connect the graph. Okay. Now that we have both graphs drawn, okay, we are going to look at this graph all together. Okay. Is there a point of interest that happened when we graphed both of these? Right, that intersection, right? So we notice that they intersect at this point, okay? That is our answer. That's what we're looking for, okay? So we're looking for a point of intersection. And today you're only going to have one, but sometimes you can have more than one point of intersection. Okay, so looking for point of intersection, which is our solution. So you want to write these as ordered pairs, which you said. So if I write that point that I circled as an ordered pair, that is our solution is 6, 6. Okay, that is our solution. What that means is that 6, 6, that point, that is a part of both graphs. Okay, that is a solution to both graphs. All right, now we have 2 new lines here. We need to graph our first line. So our starting point on our first line is -4. The sign in front does matter. So we're going to start down at -4. Okay, to get all of our other points, okay, we use our slope, which right now is 5. Okay, help me out here. Can I use just 5, or what am I missing? Right, the rise over run. So we need that as a fraction. Okay, you cannot put 5 over 0. Because if I take 5 divided by 0, do I get my original slope 5? No, I get 0, right? So we need 5 over 1. So I'm going to go up 5 over 1 and go until you can't go anymore. And then connect your dots when you're done. Okay. Now we do the same thing for line number 2. Our starting point is -2. Our slope is -1/2. This one's different from all the others because we now have a negative slope. So our line needs to look like a downward slope or a slide. Okay, so starting at -2, we go down 1 over 2 until we can't go anymore. Looking for accuracy on this. Okay, we want our graphs to look neat so we can get an exact answer for our solution. Okay. So, do we have a point of intersection? Do the lines cross?
Yes.
They do. Why did some of you say no? It's not like a perfect point, right? However, they still do intersect, right? Okay. Yeah. So we're going to say what that coordinate is. I would call that half. So over a half and down 2. Okay. Again, most of the ones that you're going to see, they're going to work out nice. But I made this up, so it didn't work as nice. Okay. But all the examples you will see will work out nicely. Okay. Couple things I want to review. Okay, go ahead and make yourself another graph about a quarter of your page. Okay, these 2 lines I want to review. Okay, now they do look a little different, but these lines will still look like graphs, or look like line graphs. Okay, so we have y equals 3. Where do you think my starting point is?
Up 3.
It is up 3. Okay, do I have a slope? Right, I don't have a slope that says here, like it's not in the form of y equals mx plus b. Okay, so I don't have any slope. So do I know where to plot all of my other points? No. Does anyone have an idea of how I plot the line?
1 over 1.
It is not 1 over 1. If it was, our line would look like this. If it was 1 over 1. But we don't have a slope. Okay. A little trickier. This one here is going to be a vertical line. And I'm going to tell you the reasoning. So go ahead and draw your line that goes through that vertically. Okay. Sorry, horizontally. Thank you. Horizontal line. The reason is a horizontal line. Okay. This is written as like a y-intercept, right? Like we talked about a couple weeks ago. It's written as a y-intercept. So this y value right here at 3, that is the only y value I want to touch. Okay, so if I go horizontal, do you agree this is the only y value I touch? Okay, if I went vertical, am I only touching that y value? Or am I touching every single y value? I am touching every single y value, so we do not want that vertical line. We want a horizontal line. So if you ever have a y equals number, make yourself a note that needs to be a horizontal line. Okay. Now, for graph 2, what is this written as? It says x equals 3, so where do we plot that? At x equals 3, right? That's our x-intercept. Okay. Now, that is the only x value I want to touch. So is my line going to be vertical or is it going to be horizontal? It does have to be vertical. Yep, so go ahead and make your vertical line there. That goes through that point. Again, the reason that has to be vertical, okay, if I went horizontal, is that the only x value I'm touching? No, right? Because that is touching every single x value. So for any x equals number, we need a vertical line. Okay, now, do we have a point of interest? Do we have a solution? Yeah, right here. Here's our point of intersection, so our answer is 3, 3. Okay, oh, that's hard to see. Solution is 3, 3. Okay, so remember, make sure you took good notes on this so you can remember how to graph y equals lines and how to graph x equals lines. All right. All right, here we are still wanting to be in the form of y equals mx plus b. However, looking at these lines or these equations right here, can I graph them how they are right now? Like, can I get a starting point? Can I get a slope? Can I graph them how they look right now?
No.
Why not? Why can I not look at this and be able to graph it? What's different from this to this?
Y is not.
Bingo. Y is not by itself, okay? In order to graph lines, we have to have y by itself.
Yeah.
Okay, so we have to use algebra to get y by itself. How can I get y by itself over here?
Subtract number.
Yeah, we need to subtract this 2x over. Sure, what I write down, you write down. Okay. One thing I want to talk about real quick. Okay. Can I combine these two to get negative 8x?
No.
No. Why not?
Because x is 16 x.
Right. You cannot combine x's and constants, right? They have to stay like terms. So what we have left is 3y equals, we just write them separately. Negative 2x minus 6.
Yeah.
Is y by itself yet? No. Yep, divide by 3. Do I just divide the negative 6 by 3 or do I divide everything? Yep, everything. Okay. I like to think of them separately, so I'm dividing every term by 3. Okay. What happens is we're now left with y is by itself. Does this come out even? No. I'm going to keep that as negative 2/3 x. What is negative 6 divided by 3? Negative 2. Now, does that look like something we can graph? Yes. Okay, so here's my first equation. What about the second equation? Can I graph that yet?
Subtract x.
Yep, we got to get y by itself, so I'm going to subtract x. So we get 6y equals negative x plus 6.
Divide 6.
Yep, last step, divide 6 by everything. So we get y equals, I want to bring something up real quick. A lot of you are going to want to do this. Negative 6x plus 1. Can someone tell me what's wrong with that? What did I do wrong?
Combine them.
I know. What did I do wrong in this step right here?
You didn't make the x a 1.
Correct. Good. So let me erase what I did there. Okay. Zoe, what did you just say? Because it was really good.
The x a 1.
Right. Technically, in front of this is a 1, right? A negative 1. So this should turn into negative 1 over 6x plus 1. Okay. All right. What I want you to do is go ahead and draw yourself a new graph. Okay. I want you to try and graph those two equations and find your solution. Go.
On our graph paper.
Yep, graph paper. Okay, one thing I want you to keep in mind is they have negative slopes. So what should your lines look like? Down, yep. So draw yourself a little note. Both of our lines should be a negative slope going down. All right, plotting the first one, what's my starting point on equation 1? Yep, b is negative 2. Am I talking about the x or y-intercept? Y-intercept, so we're always going to start on the y-axis. Where do I get all my other points from? Yep, the slope, negative 2 over 3. What I noticed a lot of you did is you graphed it incorrectly because of the difference between a positive and a negative slope. Okay, so what I want you to do to help you with that, I noticed this is negative, yes? Okay, so what should a negative slope look like on a graph? Should be looking down. So I want you to draw that line so you can double check. Okay, your graph should look like this, going down. Okay, so from there, from our starting point here, we're going to go down 2 over 3. Okay, what a lot of you did was went this way. Is this going to make a negative slope? No, so you got to make sure to go the other way. Make 1 point and then check to see if you went the right direction. Okay, before you plot the whole line. So your graph should look like this. How do I know how many points I need to make? Yep, go until you can't. Good. So my second graph here, what's my starting point? Positive 1, remember on the y-axis. What's my slope? Negative 1/6. Again, make yourself a note. What should my graph look like? Going down, right? Negative slope. So starting at our starting point, we go down 1 over 6. Can't go any more this way, so what happens? Go the other way, yep. And then make your line. What do you notice? Do we have a solution? Oh, it's not that. Yep. How do we know what our solution is? Where the lines meet. I don't know why it's not letting me make my line here. Good. I don't know why it's not letting me make my line there. So we'll just go with that. Good. Where they intersect is here. Do I just want you to circle that point? No. What's our answer here? Someone said it. Yep. X value first and then the y value. Remember, always in the order of x, y. So our answer or our solution is negative 6, 2.